My name is Munish Raja. My topic is improvement of process quality towards the achievement of desired production yield. A case study done at Parivar Roca Private Limited. Today topics, the listed topics are mentioned. The abstract is the aim of this paper is to improve the process quality towards the achievement of desired production yield and casting of a complicated pattern. A typical ceramic sanitary manufacturing process utilizes uncontrolled natural raw materials, skill of laborers and the environment. So, the critical patterns may go wrong in a complex environment of the workplace. These mistakes will result in defective components. So, quality control serves the purpose of detecting the defective components, avoiding them from moving on the next process. Introduction is, in India, the traditional ceramics manufacturing quality is an essential factor to convert a raw material stage to finished product stage. In the Parivar Roca Private Limited, they are one of the oldest business houses in India. Parivar provides overseas market of South Africa, Sri Lanka and the Middle East and a host of other countries also. They ranked in 2007 10th best sanitary ware manufacturer in the world. Currently, Parivar having 5 units, 5 manufacturing units in India, located at Ranipet, Perundurai, Alvar and Devas and Bhiwadi. My study has carried out at the Ranipet plant at Vellore, revealed that obviously there is a shortage in production for their entire product range and also they are not able to achieve 100 production yield. Especially the critical patterns they are obtaining only 50 to 70% of production yield. So, the purpose of this study to improve the process quality and reduce the manufacturing cost of critical patterns. Based on my objective, I have done literature review. Those are mentioned. The methodology, the Parivar Ranipet plant, existingly they are using following methodology: enterprise resource planning and warehouse management, barcode technology, and 5S principle for housekeeping. Still, they are facing rework, repair, and wastage. So, the new proposed methodology to be used to minimize the rework and repair and wastage. Based on literature review, we have suggested process FMEA, SPC tools, and skill matrix analysis to reach our objective. Next is implementation of selected tools and techniques. The basic implementation procedure for process FMEA. These are the steps we are follow. First one is assemble the team, then gather and review relevant information about production process, and identify the item which would be the critical. Then identify the function of critical items, failure of critical item, and what are the effects occur in the critical item. So what is the root causes for critical item occur in the critical item. Based on that, we will evaluate the risk and analyze the risks. Based on that, we prioritize and assign the corrective actions. First step is assemble the team. During the initial development of process FMEA, the responsible engineers are expected to directly and actively involve representatives from all affected areas. So the production manager, quality engineers, design engineers, shift officers, shift supervisors, senior workers, they are effectively involved for this study. The information gathered about Ranipet plant. There are majorly 3 operations are using. One is body making and glazing. That glazing means painting. Then casting operations. This is the flow chart of entire production process of sanitary ware manufacturing. So entire production details for a Ranipet plant. The production details for mold making, casting, drying, glazing, firing, and slip making. What are the raw material we use? How much rejection they are facing? What are the average capacity? How much they produce? How long they are taking for production? And manpower, how they are utilizing. For the details are mentioned in that column. Now we have to identify the critical item. In the Ranipet plant, they totally have 68 patents. In the city, next 24 different color products and 1,560 stock keeping units they are having. From that, the following selection criteria we are using to identify the critical item: the market demand of the product, cost of the product, recovery rate of the product, criticality of the product, scope and wastage of the product. This is a product list of Ranipet plant. They have total 68 patents. From that we have shortlisted top 10 rejection items. From that, number 6, code number C0264, they have average overall failure is 62.1. This is most critical item we have taken based on comparison of loader and loader versus finished product. That name is Cardiff valve pan. So introduction about that selected pattern. Cardiff valve pan pattern model is most critical, high valuable and high rejection pattern than other pattern. So this study focuses to control the rejection and to improve the production yield for the particular pattern. For the first test experiment, I have taken for this one, Cardiff valve pan. The importance of Cardiff valve pan is it's covered 20%, 2% of overall rejection rate. The mentioned the global yield in the sanitary ware product 85%. In the Parivare manufacturing unit, they are yielding 75.09%. In the Ranipet plant, they are facing overall rejection 24.91%. Which I have selected top 10 rejection model. Failure amount is 7.25%. The critical item which I have selected, Cardiff valve pan, it's contain 2%. So if we improve the 2%, the overall production yield also will increase. That's why that is important of that Cardiff valve pan. So now we have to identify the bottleneck process in the Cardiff valve pan production. The following operations are there in the following the for making Cardiff valve pan: the body operation, glazing, firing, and loading and unloading. In that, percentage of failure in each stage of Cardiff valve I have mentioned in the figure. The overall failure occur in the Cardiff valve pan 62.1%. From that, in body operation 49.54%, glazing 6.62%, kiln for firing operation they are facing 3.42%, and loading and unloading 2.51%. So based on the rejection rates sequence, this study decide body operations is the bottleneck process compared to the other process of Cardiff valve pan. Now the root cause is to be analyzed for its bottleneck. For that, I have selected SPC tools like SPC tools to identify the potential problem of the bottleneck operations. After studying the body operation, this project sequentially constructed the process flow chart for body operation. In this process flow chart, so based on the potential problem, the cause and effect diagram has been constructed for Cardiff valve pan. These are the majorly occur in body operation: demold crack, bowl crack, body print course, faulty cracks, clay dirt, rim crack. These are the failures. So how how these failures occur, what is the reason, what is the causes for this failure. I have found from the cause and effect diagram. For example, for demold crack, the mold quality, strip variations, weather conditions variations, releasing time variation. These are the reason to occurring demold crack. Based on that, I have analyzed all failures. What are the root causes by using cause and effect diagram. The defect concentration diagram, it used to clearly identify the surface defect based on that picture. Where demold crack exactly occur, where some crack exactly occur, where bowl crack exactly occur, major cracks from the cause and effect diagram. Next, from the defect concentration diagram, the root causes for front view defects. The front view defects, what are the failure defects are occur, demold crack, some crack and bowl crack. What are the potential causes? This causes is taken from cause and effect diagram. Then likewise the side views defects, what are the causes, and bottom view defects, what are the causes. We have easily found out from defect concentration diagram. This check sheet indicator February 2008 collection data. What are the failures occur in the body operation? How many times occur? The details are indicated. Based on that check sheet, we have arranged attribute data by using check sheet. Through this chart, user can quickly and visually identify the most frequently occurring type of defects. For example, demold crack is we give the rating for these defects by using Pareto chart. So body operation is analyzed based on selectors SPC tools, which are mentioned table 3 is done. Remaining process like glazing, body operation, glazing, firing and loading are also analyzed similarly, and the results are mentioned in the table 4 next. After the analyzing, identify the defects and its root causes using SPC tools, it is just suggested for risk analysis of the potential failure. So for the risk analysis, I have selected for process FMEA table by using the result of analyzed through SPC tools. So what is the risk analysis? Risk analysis is equal to risk priority number. It is the multiplication of severity of failure, occurrence of failure, and detection of the defect of the failure. Sorry? This is the process FMEA table. What are the functions we are in the body making operations? What are the failure motor releasing problem, root cause for water mixed with runoff sleep, root cause for loading defects. Based on this potential mode of failure, we give the rating, severity rating and occurrence rating. Based on the severity, occurrence and detection, we rated the RPN number. Based on the RPN number ranking, the major risk failures are shortly.